This is TMUA question of the day, day 21 hints with stopmaths.com and Tobin Payne. So our A-Level Plus question today, we've got a speed, distance, time approach, and we've got simultaneous equations, presumably, because we've got x and y, and there's no mention that they have to be integers, so we're unlikely to go down Diophantine equations route. Always be super careful when you're looking at speed, distance, time, because we know, for example, if you were to cycle, say, to work at 10 miles an hour, cycle back at 12 miles an hour, your mean wouldn't be 11 miles an hour. So sometimes things happen differently than expected. So try and set up some equations. They're hinting at that anyway with the x and the y, and just be really careful that they do actually make sense. But this one isn't too bad, so you should be all right. Now, question 22 is one that Tobin's rated as a 9 out of 10, which always concerns me whether I'll even be able to do it. But the thing about this question is looking at what form they've chosen for x cubed. All of them are linear. So if we think about the function that we're given, we know that x squared is linear. So x squared is going to be equal to px plus q. Now, we want x cubed, but we want it in a linear form. So what can we do to get x cubed as a linear function? What we should see, and we note again, we've got this p and q positive integers, so we're thinking some sort of factorization probably. It might be that the constant term that you get is something like p squared q, and you look at in fact, all of the constant terms, interestingly, are prime, aren't they? But if we look at the coefficients of x, we've got 4, 8, 8, 10, 26. So they can all be factorized. So I suspect that any successful attempt to do this is going to be dependent upon you being able to express x cubed as a function of p and q in a linear fashion, and then being able to compare coefficients and look at factorizations. So a classic kind of TMUA graph question. Again, standard sort of approach. What happens when x is 0? What would y be? Are there any lines of symmetry? How do we check for lines of symmetry? How do you check for a line of symmetry in the y-axis? How do you check for a line of symmetry in the x-axis? What would happen as x gets very, very large and positive? Is that even possible? What happens as x gets very large and negative? Is that even possible? All the standard kind of skills that we will be talking about over and over again are really worth remembering and implementing in any question like this. Now we get to our logic question. So our logic question here is a question 10 from a senior maths challenge, so not the worst. We've got 3-digit numbers, and we're using different digits from 0, 1, 2, and 3. I always like, if I'm doing something like this, to just draw 3 dashes, make me think about the digits. And then I start to think about constraints. Any of these counting questions, I've said this before, think about constraints. Now, it's, for example, where can the 0 go? Is there a constraint on the 0? If a number is divisible by 6, is there a constraint on any of these 3 choices? Start to get your constraints in, and then you'll start to see how many options you have. Hope this video was useful. Any feedback, always appreciated. Thank you.